Welcome to this explainer. Now, if you're a platform engineer, an AI architect, or basically anyone whose day job involves managing site reliability, you already know that building with AI agents is incredibly exciting right now. But you also know that, under the hood, modern AI agent architectures are fundamentally fragile. It's like we're building skyscrapers on sand. So today, we're kicking off a deep dive into the source architecture of GhostMesh. We're going to explore exactly why our current way of managing AI workers is breaking down, and how we can build a durable, governed system instead.
Okay, the absolute core philosophy of the GhostMesh architecture can be distilled into just 4 words: persistent system, temporary intelligence. We are completely abandoning this hype-driven idea of building immortal AI brains that just sit in a permanent chat window. Instead, we're shifting to rigorous systems design. The intelligence is treated as just a temporary worker, while the system itself holds all the permanence.
Here's our roadmap for this explainer. We'll start with the ghost problem, talk about why intelligence is not continuity, look at the architectural inversion, introduce GhostMesh, see what happens when the provider fails, and finally, define the continuity system.
Let's jump right into part 1, the ghost problem.
To really grasp this architecture, we have to start with a massive pain point. Why are today's highly capable AI agents so operationally terrifying to run in production? Well, it's because while they're extraordinarily capable, they are inherently ephemeral. Think about it. You can have a brilliant AI worker reasoning through a massive code base, writing validation tests, parsing complex logs. It's doing incredibly useful work. But then a session ends, or a context window maxes out. Maybe you hit a rate limit, your credentials expire, or an ephemeral runner just drops. In an instant, that worker vanishes. And because we've been building agent-centric setups, all of its state, its context, and those half-finished thoughts just vanish right along with it.
So, this begs the ultimate question. What happens to the work when the worker disappears? If you're an SRE, you know the exact visceral frustration I'm talking about here. The agent drops the unfinished thought, and suddenly you, the human operator, are forced to step in and become the system's memory. You have to reconstruct the prompt, re-explain the entire context, and basically carry the state over to a new session by hand. It's a nightmare.
Which brings us to part 2, intelligence is not continuity.
We really need to break apart a massive, often unspoken assumption in AI development today. We have completely conflated 2 very different properties. Listen, intelligence and continuity are not the same thing. An agent can reason brilliantly, sure, but that absolutely does not make it a reliable system of record. Treating a conversational interface, a long chat history, or a local file dump as your primary foundation for distributed execution, that is an incredibly fragile path. It leads to lost decisions and fragmented context. At the end of the day, a powerful language model simply does not naturally equal a durable system.
So how do we fix it? That's part 3. The architectural inversion.
To fix this fragile dependency on ephemeral agents, we need a complete paradigm shift. In the legacy agent-centric mental model, the agent holds all the context, does the work, and when it drops dead, continuity violently breaks. But a work-centric flow flips that completely. In this model, the work itself has a durable identity. It has persistent state and evidence. So worker A comes in, reads the state, and does some work. If worker A suddenly disappears, it literally doesn't matter. Worker B simply spins up, reads that exact same state, and resumes right where A left off under the exact same authority. The work exists completely independently of the worker.
This flips the whole script. As the source material beautifully puts it, the intelligence did not need to be immortal. The system had to survive without it. AI workers are just transient, replaceable compute. The authority, the memory, and the state must be externalized from the model itself.
And that leads us to part 4, introducing GhostMesh.
With that paradigm shift in mind, let's formally introduce the architecture designed from the ground up to actually operationalize this inversion. This is GhostMesh. It's defined as an architecture for governed continuity across ephemeral workers. Notice what I didn't say there. I didn't say it's an autonomous AI wrapper or a cool chatbot tool. No, it is a control fabric. It's a persistent system that coordinates temporary cognitive workers across sovereign infrastructure, all while rigorously preserving durable authority and state. The mechanics of how GhostMesh actually separates execution from authority are fascinating. Now, without getting too deep into the weeds of the code just yet, you can see the core building blocks. We're talking durable work identities and persisted state planes. We use claims, leases, and budgets so these workers don't step on each other's toes. We generate explicit receipts and evidence for literally every action. Authority is strictly bounded and controlled by the human owner, and recovery is completely deterministic. Ultimately, the worker doesn't decide what's true, the mesh does. If you take just one maxim away from this entire explainer, let it be this: manage the work like an employee. Control the system like powerful machinery. We have to completely axe any anthropomorphism here. AI agents do not have moral accountability. They don't care if they corrupt a production database. So we absolutely cannot rely on their good judgment. We have to rigorously manage the integrity of the system itself.
Moving on to part 5, when the provider fails.
Look, an architecture like this sounds great in theory, but how does it actually hold up in empirical reality? Well, GhostMesh operates on the assumption that failures are going to happen. Take the August 6th GitHub Actions outage, for example. On that day, a massive external execution plane failure hit. Webhooks were aggressively throttled, workflow events were failing to start, and both hosted and self-hosted runners degraded severely. Basically, the execution provider was in total chaos.
To put this into perspective, let's look at the stark difference between reality at the provider layer versus reality at the system layer during that outage. On the provider side, webhooks were throttled and jobs were completely stalled out. But the GhostMesh system reality? It was rock solid. It preserved the exact intent and authority. Claims and leases were maintained accurately. Sure, runner capacity was missing, so no work could actually happen, but crucially, there were 0 unauthorized mutations or silent corruptions. When jobs inevitably dropped half-finished, the mesh caught them. The exact rollback state was retained perfectly for safe recovery.
The reality of that day was that work was certainly delayed. The execution plane was completely degraded, but the safety plane held more strongly than the execution plane. This incident exposed a really vital architectural truth. You cannot tie your system's continuity to a single SaaS provider's uptime. It perfectly validated the need for provider-neutral, sovereign execution semantics, where the mesh, not the provider, is the ultimate authority.
Finally, let's wrap up with part 6, the continuity system. Let's bring this all together. What does a governed continuity system actually mean for your daily operations? It means you get to graduate from a world of transient AI magic into a reliably operable system. Accepted work can no longer just disappear into the void if a webhook drops. Execution state can never depend on whether your laptop managed to stay awake while you went to grab a coffee. When an AI agent hands work back to the human owner, it has to actually work at the intended route. It can't just slap a mechanically green checkmark on a broken deployment. It means your execution providers become completely replaceable and your system automatically chooses the least expensive, most deterministic route for the work rather than defaulting to some massively expensive LLM for every tiny task.
GhostMesh exists because our original problem wasn't a lack of intelligence, it was a lack of continuity. We've clearly established that if the work lives primarily inside the agent performing it, your system is inherently fragile. But if the agent is no longer the system of record, if the mesh itself has to hold all the state, the authority, the evidence, and the leases, what exact architecture makes that possible? How do you actually build those control planes? Well, that is exactly what we're going to unpack in the next explainer in this series. You definitely won't want to miss it.